All right, good evening, everybody. How are you doing? Good? Well, welcome, everybody. It's really a pleasure to have you for the kickoff of the year 4 of the Carbon to Value Initiative. My name is Frederick Clerc. I'm the director of the C2V Initiative, and I'm also the interim managing director of the Urban Future Lab at NYU Tandon, one of the 3 operating partners of the Carbon to Value Initiative. I'll be your host for the night. Pardon my accent, my French accent. I hope if 50% of you guys understand what I'm saying, that's great. That's a great achievement. I want to welcome you all, whether you're local to Houston or whether you've traveled from far away. I know that we have quite a few people who actually traveled. So thank you for that. And also thank you for people who are joining us online. I know that we had many registration online as well. And thank you for your time. Thank you for being here. We're here to celebrate the year 4 cohort. After a lot of selection, exciting to present you this new cohort. And maybe a little bit of a word about the C2V initiative, Carbon to Value. It's really something quite unique around the world. We are creating a first of its kind collaborative ecosystem for carbontech startups, leading corporation, government, and experts to identify partnership opportunities. And the end goal of C2V is to build new carbontech value chains, making carbontech as cost effective as possible and deploy carbontech at scale. You should probably click on this. That's me. One really key feature of C2V is the Carbontech Leadership Council. And that's a really incredible group of government, non-for-profits, and corporates. And this is one of the key ingredients to the success of the program. And it's really what we are fostering collaboration outcomes with this group. The CLC are really committed to providing our startups invaluable support, thought leadership, and collaboration opportunities that is really needed to propel carbontech forward. This year, we are very excited to welcome 6 new CLC members, in addition to all our existing members. Caterpillar, CO2 Value Europe, Evonik, Energy Impact Partners, Veolia, and Shell. Of course, the program wouldn't be what it is without the innovators. And over the last 3 years, we have already worked with 26 very innovative startups across the carbon management value chain. And from point source stack to, of course, a lot of CO2 conversion companies, as well as biomass-based and CDR companies. We're trying to really cultivate that very diverse group of companies that we need to build these value chains. In fact, I'm quite proud to announce some recent wins from previous alumni. A recent one is Carbon Free, who was part of the year 1 cohort. They actually signed a commercial agreement to capture 50,000 tons per year of CO2 at a US steel mill in Pennsylvania. With Fluor as an EPC partner. So that's a great result from the C2V ecosystem. 2 other recent wins, we had Carbonova and EcoLocked from year 2 that recently raised respectively 6 and 4 million. So, always a good sign when you're able to raise money moving forward. And just yesterday, Air Company, which was in our year 1 cohort, announced a close of their Series B at almost $70 million. So really congrats to them. In terms of how we measure our success and our outcomes, it's always difficult to measure the success of an ecosystem. And these are just a few numbers. We worked with 26 startups. They've raised close to 450 million by now in follow-on funding. And one thing that we're fostering is just creating these new connection, new business relationship. And we've created over 500 new business relationships that have yielded 9 publicly announced partnership outcomes and a lot of other pilot and GDAs and licensing agreement opportunities for the companies. So now let's talk a little bit about year 4 and the pool of application. We saw a very strong application pool, about 100, over 120 applicants this year, coming from 29 countries. So actually very nicely diverse application pool. And we saw applications from different technologies, carbon conversion, DAC and point source capture, carbon sequestration and removal. And you will see in the diversity of the cohort that they are really well represented, these different categories. But you'll learn more about the year 4 cohorts just in a minute when they will present. But next, I'd love to invite on the stage Manon Chapa-Alarson. She's the Greentown Houston Director of Partnership, and she will make a few welcoming remarks. So Manon, welcome to the stage.
Thank you, Fred. I guess I should apologize for my accent as well. Conference too. I was going to make a joke that it's like not the Eurovision, but I guess it's more the United Nations of carbontech, because I've met a lot of the startups and a lot of them have traveled very far to be here. Anyway, good evening, everyone. Welcome to the kickoff event of year 4 of the C2V Cohort Initiative. My name is Manon Chapa-Alarson. I'm the Director of Partnerships here at Greentown Houston. Thank you all for being here with us today to celebrate the beginning of what I'm sure will be another amazing year for C2V. I wanted to tell you a little bit about what we do at Greentown, and then also how we're very proud of collaborating with Fraunhofer USA and the Urban Future Lab on this C2V initiative. For those of you who are visiting us for the first time, howdy, welcome to Houston. Our mission here at Greentown is to accelerate climate tech innovation and commercialization by empowering entrepreneurs and enabling collaboration. We are a global, emphasizing on global, community of entrepreneurs, corporate partners, investors, and policymakers, and we're all working towards the same goal: solving the climate crisis through entrepreneurship and collaboration. We are here at Greentown to provide a supportive ecosystem that will allow the startup to test, scale, and hopefully commercialize their breakthrough technologies that address some of the world's most pressing challenges. Since our founding in 2011, we helped more than 500 startups, and they raised more than $6.5 billion in funding, billion with a B. And I know that I think approximately more than half of that funding was in the past 3 years, so huge achievements. And those would have not been possible without the communities that we've been forecasting here in Houston as well as Boston. So obviously collaboration is at the heart of everything that we do. And that's why we partner with the world's leading corporations to help those startups scale their solution and accelerate the path of innovation. Corporate partners provide critical resources. Some of you have taken a tour today and you were able to see those resources here in the space. And those can be game-changing for startups and for entrepreneurs. It can be game-changing for their ability to scale and to deploy their technology around the world. We know that decarbonization is a huge challenge, and not one organization, not one company, not one person can solve it alone. Everyone has to do their part. Our hope at Greentown Labs is that C2V continues to fuel these game-changing collaboration and building a powerful carbon tech ecosystem that can empower those inspiring entrepreneurs you will hear from today, and hopefully bring on the next generation of entrepreneurs as well to fight and win that climate battle. Before giving the floor to the entrepreneurs, I wanted to thank the whole C2V team for their tireless work to make this program a success, and for all of those that are here with us today and those that are not. I want to thank Urban Future Labs at NYU Tendon School of Engineering. Sorry for the French pronunciation. Fraunhofer USA teams as well for being such incredible partners for the past 4 years. I want to thank the CLC members for being here with us tonight, for supporting this wonderful initiative. On the government side, the Consulate General of Canada in New York, our carbontech expert and NGOs, Carbon 180, CO2 Value Europe, Energy Impact Partner, XPRIZE, and of course our corporates, BASF, Caterpillar, Evonik, Fluor, Johnson Matthey, Shell, Veolia, and WL Gore and Associates. All right, and now back to Fred and the year 4 cohorts.
Thank you, Manon. I'm actually jealous of your accent, so good job. All right, so the moment we are all waiting for, introducing the year 4 cohort. We are really excited to welcome this year Ardent, Carbon Blue, Macrocycle, Maple Materials, Oxidus Energy, Flare, Renew CO2, Seabound, and Seek and Fuel. So in this next part of the program, we're going to invite each startup to present and share a little bit more about the company and the technology that they're working for and why they're excited to join C2V. Each startup will have 3 minutes to share their core innovation, but keep in mind, this is not a pitch, not an investor pitch. There is no Q&A, and you'll definitely have a chance to go and talk to them at the reception time. This is meant to spark your curiosity, and we encourage you to connect with them during the reception. So with no further ado, I would like to welcome joining us from Newcastle, Delaware. Please join me in welcoming Christine Parrish, VP Technology Solution at Ardent.
Hello, everyone. We're really excited to be here with you in Houston tonight. So my name is Christine Parrish, and I'm with Ardent. And tonight we're going to talk about engineering the inevitable. So specifically decarbonizing with the universal adapter that is membrane technology. So heavy industry is really lacking a pathway for decarbonization. Transportation has electrification, energy has renewables, but there's the number that keeps us up at night is the 600 gigatons of CO2 that will be emitted by 2070 by assets that are in the ground today that are critical to making the building blocks that we all use to make everything that we use in our daily lives. And so we need to give them a path to decarbonization. And point source carbon capture is a practical way to do that for much of this heavy industry. And separation is the biggest piece of the point source carbon capture puzzle. And there's a whole lot of opportunity there when we reduce this and simplify point source carbon capture, when we reduce the cost past incumbent solutions like amines that require a whole lot of scale, and when we address the needs of plants as they exist today, rather than how we expect them to be by 2030 or 2050. And so Ardent is doing that and unlocking practical near-term point source carbon capture. And that's really enabled by 3 things. The Ardent Optiperm membranes win on cost because our proprietary membrane technology is very rugged, which simplifies the balance of plants and lowers the capex, and works at lower pressure, which means that you need less energy to do it. It's also a modular system, which makes it easy to use, and there's no chemistry component to the system itself, so there's no waste that needs to be addressed from the system. And then the membranes themselves also are a universal adapter and give you a lot of flexibility. So whether your plant is close to sequestration and needs high purity CO2, or whether you have on-site utilization that might not need as high purity, membranes can enable you to do that. And Ardent is filling that gap with a proprietary technology that is proven to scale, part of a platform, and uses existing manufacturing technology so we don't have to reinvent the wheel. And there's a whole lot of opportunity for cost reduction depending on what you want. And these are numbers that happy to talk about later, but are always plant specific based on your energy use and the final CO2 purity. We are addressing larger and larger markets as we go forward. So starting with applications today where the infrastructure already exists and moving to the really big targets like power gen. We have 3 pilots in 3 very different flue streams with steel, cement, and a petrochemical refinery now. And we're really excited to see the membranes continue to perform well in 3 very different applications. And we realize that this is a silver buckshot approach, not a silver bullet. Ardent will not be able to do the whole, but we are just part of the solution. So if you're an investor, we've just opened our Series B. If you're a partner who can collaborate as part of the value chain, or if you're a customer, we'd love to chat about your pilot. Thank you.
Thank you so much, Christine. And next up, all the way from Haifa, Israel, please join me in welcoming Dan Deviri, CEO of Carbon Blue.
Thank you, Frederic. So as Frederic said, I am Dr. Dan Deviri, the co-founder and CEO of Carbon Blue. And our mission in Carbon Blue is simple. It is to provide existing industries the technological means to decarbonize their core business. And that is pretty presumptuous, so I would be more specific. To do that, we are developing 2 technologies. The first technology, which you see on the left, is a technology to capture carbon dioxide from water. We mineralize using a material called lime or calcium hydroxide. We mineralize carbon dioxide that is dissolved in water in a way that causes the water after decarbonization to reabsorb back carbon dioxide from the atmosphere, so leading to net atmospheric reduction of carbon dioxide. And we are left with that, which is a mineralized form of carbon dioxide that we can carry around. The next thing we do with that, that's the second technology that we are developing, is exactly the reverse of what I just said. We're taking this mineralized carbon dioxide, release the carbon dioxide in gas form from it using energy, either electricity or relatively low temperature heat, and regenerating the lime we used to facilitate further cycles of carbon capture from water. So those technologies can be implemented in different time and space, but when combined together, it forms a pretty unique water-based carbon dioxide removal technology, which we now pilot. We're developing a pilot together with a desalination plant, brackish water desalination plant, because desalination is a unique example of an industry that both has water and requires carbon dioxide for their operation. And based on the prototypes that we've done with the water, it informed the techno-economic assessment for what we expect to reach at large scale for our technology. But desalination is only the first step toward the larger vision and more significant vision, which is to connect industries using water with industries that requires carbon dioxide. Basically installing the mineralization technology on a very wide range of industries that has water infrastructure. It both helps to reduce their operational costs due to technical reasons, and we can carry around the carbon dioxide, again, in a solid form without pipelines or any specialized infrastructure, and bring it to other industries that requires the carbon dioxide, ranging from Coca-Cola to carbon storage companies or carbon utilization companies. And that way, our technology can support both the scale up of the CDR, the carbon dioxide removal market, and the circular carbon economy market for a sustainable and greener future. Thank you very much. Thank you for your time. If you have any question, find me later.
Thank you, Dan, so much. And thank you for traveling from so far away. Next up, a little bit closer, but not quite close, joining us from Somerville, Massachusetts. Please join me in welcoming Stuart Pena-Feliz, co-founder and CEO of Macrocycle.
Today, 85% of all the plastic that is globally produced ends up in our landfills, in our oceans, or it gets incinerated. This results in 6% of all global CO2 emissions to be associated to the plastic life cycle. A linear economy that is poised to grow to almost $1 trillion by the beginning of the decade, and only getting worse from there. To start resolving our plastic crisis, Macrocycle is introducing its first product into the market, the Macrocycle PET pellet, a virgin-grade plastic that is derived from lower-value plastic waste that can be produced with zero carbon emissions and no green premium required for adoption. A product that has already been requested by 20 different customers, including paid pilots by Fortune 500 companies. So why are these companies excited over our value proposition? Well, the traditional technology in the industry is mechanical recycling, a low-energy technology that can only downgrade the quality of the plastic, as it is unable to remove colors and contaminants, and it makes a non-virgin quality product. The technologies that can address this quality dilemma are the advanced recycling technologies. They rely on breaking the polymer all the way down to the building blocks, the monomers, and then selling them into the petrochemical industry to produce the original polymer. This requires a green premium to be sustainable due to their high energy demand, and is dependent on the petrochemical industry that produced the emissions in the first place. Macrocycle comes in and is able to resolve all of these problems. Instead of breaking bonds, we're making new ones. Through our patented solvogenesis technology, we retain the structure of the polymer, and instead of breaking it, we create microcycles. This new intermediate allows us to bypass the petrochemical industry entirely, and we can turn it back into the linear polymer state in a higher virgin grade quality compared to the starting material. This allows us to produce a virgin grade product that serves as a drop-in solution for our customers that we can sell at market rate and still accomplish incredibly high contribution margins. This is what it looks like. We can take the cheap and dirty feedstock from the industry, put it through our reactor, and create these intermediates while removing the contaminants from the plastic, such as dyes and contaminants. We then produce a virgin grade product ready for the high value rigid packaging applications. And we can do this with 80% less energy compared to traditional means of plastic production. And the remaining 20% can then be fully electrified with renewable energy to achieve recycling with zero carbon emissions. This is a process that we have already scaled up 50 times since of what we have already demonstrated at the lab scale. And we are going to continue to scale this up even larger from this. My name is Stuart. I used to operate Exxon's first recycling unit just across the San Jacinto River from here. And after going to MIT, I met my co-founder and the creator of this technology, Dr. Jan, and we've decided to embark on this journey to start solving our plastic crisis. We've been fortunate to surround ourselves with a very strong, powerful team, but we won't be alone in this journey. If you can assist us in this journey or want to inquire about future financing opportunities, please connect, as together, Macrocycle can create a cleaner, more circular future for everyone today.
Thank you so much, Stuart. Next up, joining us from the opposite coast, from the West Coast, from Richmond, California. Please join me in welcoming Drew Reed, co-founder and CEO of Maple Materials.
Great to be here with you guys. So again, yeah, my name is Drew Reed. I'm the CEO and co-founder of Maple Materials, and we convert CO2 into graphite and oxygen. So graphite anode material for lithium-ion batteries is one of the largest markets for graphite. It's expected to grow from $8 billion today to $51 billion by 2030. And as you can imagine, the EV battery market has a lot to do with this. So what we're really interested in and excited about is that in the US and the EU, these are two of the fastest growing markets for EVs and largest markets, but we account combined less than 1% of global graphite anode material production. And really a lot of that has to do with how graphite is actually made. So it's made from oil in this very complex, expensive, and time-consuming process. And on top of that, the graphite that's used in EVs is one of the most carbon-intensive industrial materials that's in use today. And that puts extreme limitations on where you can actually manufacture this for the EV market. So at Maple, we're doing things differently. We turn CO2 into graphite anode material for 1/3 the cost. Our projected cost at scale is $2,000 per ton. And again, this is 1/3 the cost of conventional approaches that are used from oil in China. We have a revolutionary new approach where we can cut our production time down to 1 week. And we can do this without, without emitting any CO2. The core behind this is our patented molten carbonate electrolysis process. And this is what we're using to transform CO2 into graphite and oxygen. So beyond this being low cost, what's really exciting is that every aspect of this is electrically driven. So if we're on a renewable grid, like a big hydroelectric grid, this is actually a carbon negative process. So we're consuming and eliminating 3.7 tons of CO2 for every ton of graphite we produce. So today we're operating our production facility in Richmond, California. We're testing our anode material products with customers, and really excited to be here at C2V with you guys tonight. And really what we're looking for the program is to engage with CO2 producers, new sources of CO2 to convert into graphite, not just for anode material products, but new and emerging products as well. Thank you.
Thank you, Drew. Next up, going back to the East Coast, joining us from New Haven, Connecticut. Please join me in welcoming Harrison Mayer, COO and co-founder of Oxalus Energy.
Hello, my name is Harrison, and I am the COO and co-founder of Oxalus Energy, and we convert CO2 into carbon-neutral fuels and chemical feedstocks. Specifically, we target green methanol. And so, as you all know, electrification is a huge solution for the climate transition. There are some sectors that can be electrified, like road transport. However, there are a lot of sectors called the hard-to-abate sectors of shipping, aviation, and petrochemicals that require hydrocarbons as a feedstock or chemical fuel. And so there are alternatives out there like green hydrogen or ammonia, but they're toxic and they suffer from energy density problems. And so this is why we target green methanol. It's an energy-dense liquid hydrocarbon at room temperature and pressure, and most importantly, it can actually decarbonize industry. You can use it for shipping fuel, upgrade it for sustainable aviation fuel, or use it for a petrochemical feedstocks. And it's already used today in large scale at around 88 million metric tons per year. But the current problem is there isn't enough green methanol out there. It's limited by the cost of green hydrogen as an input. And so we have developed a new technology that does highly efficient electrochemical CO2 conversion within one reactor. So this is very similar to hydrogen electrolysis, where you take water, zap it with electricity, and out comes green hydrogen. What we do is we take CO2 on one side, the cathode, water on the other side, the anode, zap it with electricity, and directly methanol comes out. This is a more efficient way of producing green methanol. It's at low temperature and pressure, and this means more modular, more scalable, and cheaper green methanol that can actually decarbonize the hard-to-abate sectors of aviation, shipping, and petrochemicals. This represents $1 trillion opportunity, but more importantly, this is 11% of global emissions. And so right now we're developing our electrolyzer technology in our first phase. We're scaling that up in our next phase for a commercial deployment, looking towards industrial scale. So we're excited to be here in the Carbon to Value Initiative because we're looking for partners for CO2 sourcing, methanol membranes, as well as valorization of our CO2 and understanding the government landscape and government incentives. So we thank you for your time here and look forward to connecting more. Thanks so much.
Thank you, Harrison. All right, you still got some energy. We have 4 more to go. So next up, actually joining us from Munich in Germany, we have Malte Feucht, COO and co-founder of Flare.
Thank you, and great to meet you all. I'm Malte, the CEO and co-founder of Munich-based Flare. So we enable a carbon negative future. More specifically, we've developed a new type of electrolyzer. We call it an hydrolyzer that we use for direct air capture. If you look at direct air capture currently, there are 3 distinct problems that holding it back from scale and also holding back customers from larger volume purchases. First of all, you have generation 1 approaches, like the ones from Climeworks or Carbon Engineering, that have high energy demands leading to high cost. Secondly, you have generation 2 approaches, mostly electrochemical, that rely on some type of new material or membrane, but fundamentally, those materials haven't been proven beyond lab scale and are thus not scalable. And thirdly, both generation 1 and 2 approaches require a baseload form of energy, making them not suitable to be deployed with renewables. So we are different. We call ourselves DAC 3.0. So specifically, we have developed a new novel type of hydrolyzer that you see to the left here. So this device is splitting an electrolyte into an acid and a base. Bases are pretty good in binding CO2, while acids are pretty good in releasing it. So we couple that with an air contactor to the right to remove CO2 from ambient air. The result is that this process is up to 3 times more energy efficient compared to conventional approaches. Secondly, we are fully compatible with renewables. So we can basically couple our plant with an intermittent source of energy, like a solar field, without the need for additional battery storage. And lastly, is mass manufacturable. So while the hydrolyzer is new and novel, it basically banks on existing technologies from PEM fuel cells and water alkaline electrolysis. So all of the above, our ability to couple with renewables and to be mass manufacturable while being energy efficient will allow us to reach capture costs of sub $100 at scale. So where are we today and where will we go tomorrow? So as of today, we've built a functioning pilot back at our facility in Munich. We are backed by some leading customers in the field of carbon removal, such as Shopify, Stripe, or Klarna. And we've just closed an oversubscribed 14 million seed round that we just announced actually today. Backed with this, we are racing towards our first commercial facility, which is called Project Dawn, and we will announce where we're going to build it very soon. So really looking forward to connect with all of you here, especially with partners in the supply chains and EPC to make this project a reality in less than 2 years. Thanks.
Thank you, Malte, and congrats on the race. That was news to me. So it's race time these days. Great. Well, next up, we're going in the world of marine shipping. Oh, no, actually, sorry. Of syngas production with a company called Seek and Fuel. And they are all the way from a city very dear to my heart because I've studied and lived there for 8 years, Montreal and Quebec, Canada. Please join me in welcoming Joachim Kamstra, CEO of Seek and Fuel.
Thank you, Frederick. And welcome to Seek and Fuel, where we cost-effectively convert captured CO2 into syngas. And I'm going to start with the team. Seek and Fuel was actually created out of BX Ventures, Canada's first clean tech venture studio, and Sherbrooke University. Bruna is here with us today. She's our one of the founders of the technology, together with Jean-Michel, and is our CTO, and is continuing to drive the technology forward. I'm the CEO. I'm actually here. Mark is here as well, and Hayden. And together we have a very experienced and well-diversified team to push this technology forward. So what is our approach? We use a fixed bed reactor that has a catalyst in it. And the inputs that you see are captured CO2, water, and renewable electricity. That renewable electricity is used to heat up the reactor. We need that heat as if you are in the world of chemicals, you know, the CO2 bond really likes to stay together. So it needs some pushing to get split. So together with the CO2 and the water, we convert this into a single step into syngas. The benefits of our technology, first, diverse input. And with that, we mean we don't have to worry about any impurities in the CO2, so SOx, NOx, etc. We can all easily consume that in our reactor. It's a very simplified process, which really leads to the third benefit. That is a very cost-efficient process. And if you've been in the climate space long enough, I think we all find out that selling a product at a green premium, while people want to decarbonize, that's not so easily done. So if we turn our value proposition into dollars and cents, which it always comes down to, we can create a product that offers an 80% carbon reduction without a green premium. And in certain jurisdictions, depending on the cost of renewable electricity, and on the low end side of our range, this would be Quebec in Canada. Other examples are Ontario or British Columbia. In America, it would be North Dakota, Nebraska that have low cost renewable electricity prices. In certain cases, we can even produce our product below the threshold of producing it with fossil fuels like natural gas. As everyone has said, we cannot do this journey alone, so I'd love to connect with you and partner up and do it together.
Thank you, Joachim. All right, let's stretch. Next up, we have all the way from Somerset, New Jersey. Please join me in welcoming Peter Shepard, COO of Renew CO2.
Thank you. Peter Shepard, COO of Renew CO2. We're really excited to be part of the C2V Cohort 4. Creating value from carbon is very difficult. And so having the support of the network of the C2V and Greentown Lab will be extremely valuable. Renew CO2 is unique in its ability to produce carbon negative liquid products directly from CO2. We think that gives a lot of advantages in terms of cost and capital. The products we're focused on range from chemicals to fuels, and our current focus is SAF. Our SAF process is very compact and low cost. We start with CO2. We put that through an electrolyzer along with water and electricity. We produce a C3 called methyl glyoxal, which happens to have a fair amount of hydrogen already associated with it. That aldol readily couples to the desired chain length. We hydrogenate that, and we have SAF. We require no Fischer-Tropsch processing, so very efficient and very low energy consumption. We can meet the cost targets that the industry is demanding. Our OPEX is estimated at less than $2.25 per gallon, and our total cost, including CapEx, is less than $3.25 per gallon. That compares extremely favorably with the current cost of Jet A, as well as the other power to X approaches. Life cycle emissions, we reduced the CO2 footprint by over 94%. Again, very favorable relative to the other approaches being pursued for SAF. And again, that stems from our very efficient electrical conversion, as well as the lack of Fischer-Tropsch processing, which really gives you energy and capital penalties. We've made tremendous progress in the last 24 months. The electrolyzer, we've scaled 100-fold. We've operated that for 1,000 hours of continuous operation. We see more than 80% selectivity to the target molecule, methyl glyoxal. The adult coupling step, that occurs at low temperature using off-the-shelf technology and catalysts. We get more than 95% selectivity to the target molecular weight range for SAF. HDO, that process is yielding less than 3.5% oxygen in our final product. And that again uses off-the-shelf technology and catalysts. So we can leverage tried and true proven technology for the downstream of our process. What's really novel is the catalyst that we've developed. We built our first containerized system. We'll be shipping that to VW in Germany. They're going to operate that using captured CO2 and to produce fuels and chemicals and use that information to pressure their supply base to provide them with more sustainable materials. Our advantages in summary: low carbon footprint, affordable, and leveraging a very globally available feedstock. We like to think of it as ASAF, so affordable SAF. So come decarbonize with us. We're raising a seed round of $8 million, targeting a close the end of this year. And if you'd like more information, please click on the QR code on the left or grab me afterwards. Thank you for your attention.
All right. Last but not least, we are crossing the ocean again. And joining us from London, England, let's welcome Alicia Frederickson, CEO of CBound.
Hey everyone, thanks for having me. So I'm Alicia Frederickson, co-founder and CEO of CBound, and we capture CO2 directly on ships. So as we've heard a little bit about already, the shipping industry is still stubbornly hard to abate, and it's lacking solutions to meet brand new global regulations as well as increasing customer demand. So the fuels of methanol and ammonia, as much as they're promising, and I actually used to work at a methanol company, they're still maybe 10, 20 years away from being in sufficient, reliable supply. And efficiency solutions are insufficient for reducing a high volume of CO2. So at CBound, we capture carbon directly on ships to extend their operational lifetimes. So this is faster to market than carbon neutral fuels. We can retrofit existing ships and design it into new builds. It's modular and flexible to scale up over time, and we can reduce all the way up to 95% of CO2 emissions on a given ship. So CBound system leverages a second generation carbon capture technology called calcium looping, and we fit this into modified 20-foot shipping containers. Obviously a simplification of our approach, but essentially we react CO2 in the exhaust gas coming out of a ship's engine with lime in order to create limestone or calcium carbonate, so similar to carbon blue. So it's a very simple process. It's non-toxic. It's low energy consumption. It's actually releasing energy when it captures CO2, which can be recovered. It's dual purpose in that it also captures sulfur to meet other regulations in the industry. And finally, it's a fully modular system. So our approach is simpler, cheaper, and more scalable than alternatives. While this is a brand new category of technology, we think of the conventional approach we've seen some others attempt is to do everything on board, capturing the CO2, regenerating it, and liquefying it on a given ship. But this results in high CapEx equipment, high energy consumption, and difficulty scaling because ports aren't equipped with liquid CO2 receiving facilities. So we just capture CO2 on board, and then we regenerate on shore to leverage economies of scale. Last year, we completed a world-first pilot, capturing CO2 at 78% efficiency, together with Lomar Shipping and Hapag-Lloyd, de-risking our tech, gaining our sea legs, and proving that this technology works at prototype scale. Next year, we're launching our first commercial product, so our first containerized kind of full-size systems, and we'll be installing and testing it on a couple of vessels before continuing to install it on about 10 or so ships in 2026. Thank you.
Thank you, Alicia. And let's give them a last round of applause to all the startups who presented tonight. Congratulations again. With that, I want to thank you all again for coming tonight, including those who are watching online. I hope you enjoy the speaking program. And now it's time to network and share some food and drinks, which is probably the best part after the presentation, of course. This will be served just right there, and I will look forward to seeing you there. Thank you so much again for tonight. Thank you.